Okay, welcome everybody. I'm Federico Drago from the EGI Foundation, and I am the Communications Manager of the EOSC Beyond project. Today, I'm welcoming you to the third webinar of our project, which is focusing on piloting the next generation EOSC in an experimental network of nodes. We have several guests today, and I will just give you a quick introduction of what we're going to discuss. These are the main results that the EOSC Beyond project is producing through its 3 years. As you can see, we have been working on next generation core services to support setup and federation of the EOSC nodes. 3 new services, which you can find here, the Core Innovation Sandbox, the Integration Suite, and the Execution Framework. And especially, what we are going to introduce today is this network of EOSC pilot nodes, which are divided in 3 different types. Here you can find some of the results that were produced by the project over the first couple of years. With all the links. Of course, you're going to find these slides also on the website later on. And today, especially, as I was saying, we're going to talk about the pilot nodes. The agenda is as follows. So I'm giving the introduction now. Then our partner, Katarzyna Lechowska from CYFRONET, will give an overview of the pilot node, the concept, the achievements, and next steps. And then we're going to have 3 presentations from 3 of the nodes. One is about METROFOOD from Oskar Chajdas, one is from LifeWatch, ERIC from Lucia Vaira, and the last one is from Instruct-ERIC by Yvonne de Jong-Leung. And we're going to have a Q&A at the end, so of course, feel free to add your questions in the Q&A box on Zoom. And of course, as usual, the webinar will be recorded and made available via the EOSC Beyond YouTube channel. So thanks everyone, and I'll stop sharing and leave the floor to Kasia.
Hello, everyone. I have a pleasure to present what has already been achieved within the project with pilot nodes. I am the work package leader of work package 15 and 16, and we support pilots in their work throughout the project. Let me share my screen. Is everything all right? Do you see my presentation? Great. Okay, so I've already introduced myself. So I want to say that over the next around 10 minutes, I will walk you through the definition or what we mean by pilot nodes in EOSC Beyond project, what we set out to pilot, what has been tested and demonstrated so far, and what comes next on the path towards federation readiness, let's say. This presentation is an opener for today's webinar. So the case studies, our use cases, pilot nodes will follow, and they will go more into details in their own development. So I'm going to keep it on, let's say, network level. And I hope you will understand the pilot nodes idea more after my presentation. First things first, what is the pilot node and why it matters? The definition of the pilot node is not easy, but let's agree that it's an entity, national, regional, thematic, or infrastructure that keeps its own governance, community, and service offering, while within the project testing and validating the technical and organizational interconnections needed to progress towards becoming a fully operational EOSC Federation node. So we are like a testing environment, right? The project that can provide some outputs that helps pilots to become ready to be a part of federation. And what else? This dual character, I would say, it's the whole point here. We are not building a network on paper, not asking people to join. Then after that, we are assessing the model through concrete pilot nodes, concrete entities, then test how federation style access, discovery, support can work and how it can work for researchers in practice. Three things make a pilot node. A real scientific user stories. It brings real resources and it plugs into federated capabilities that are being presented by core services within the project through the EOSC core innovation sandbox. And why pilot nodes matter? Science first means the network gets shaped by what, like I said before, researchers actually need. Throughout the project, we discover gaps in a real time, and a replicable model means everything we learn becomes the baseline for the future integration. What do we have here? How many pilot nodes we deal with? What types and sorts of them we have in a project? So the answer here is that we have 10 pilot nodes and they are diverse by design. It's deliberate. We have 3 or 4 families of pilot nodes, thematic, 6 of them, that spans between social sciences, structural biology, climate, biodiversity, food and nutrition. Then we have national and regional nodes. Although, I will finish my first thought and then add although. National and regional, 3 of them cover Czechia, Germany, and Southeast Europe, so it's regional one. Although Czech node can be also recognized as a infrastructure because they provide compute and storage in the project. But still, they serve as a national node here. And one typical infrastructure node, EGI, provides federated compute and storage to the network. This mixture lets us conduct stress tests of the federation model or federated model, related integration ideas against very different realities, operational realities. I mentioned already the core innovation sandbox several times, and now let me explain it because it isn't that obvious, I suppose. But it's the technical engine that enables that project, makes everything else possible. It's a pre-production replica of the pilot's network. It exists so pilot nodes can execute core services, test workflows, and break things without breaking production. Anything that succeeds in sandbox can become the baseline or basis for later further production grade adoption. I picked the 4 things that it enables, but there are more of them. You can see them on the right side of the slide. It's federated AAI testing, sign-on flows, verified across pilot identity providers and federation infrastructure proxies, service composition, discover, order, and change services from multiple pilot nodes, but inside one workflow, catalog and front office. We have 3 core services: service catalog, discovery hub, and white label marketplace tested in a federated setup. We can also add here resource catalog that enables exposing what we call research products like publications, data, tools, and so on. And cross-node user stories. So, like I said before, real research workflows tested across 2 or more pilot nodes before any potential future production rollout. Long story short, I'd say the sandbox is a place where network gets debugged before it gets deployed. Almost 2 years of the project, we have already built something that you can see here. Headline numbers from those 2 years. 10 pilot nodes are active. This is something that might seem obvious, but still, I would like to stress it out that we are still in progress and working. More than 10 scientific user stories, but to be honest, we have at least 15 of them in a different stage of development, defined, refined, and progressing. 12 core services that have already been integrated across the pilot network. 2 Krakow workshops where we were able to get together core service teams and pilot nodes, and the whole thing was co-designed there. Not to mention that throughout the project we had 2 more workshops in Athens, more related to the whole project or core services, but still the cooperation is very good here. We are working on 10 pilot node entry points. Right now moving from internal setup towards user-facing access. And 1 MVP and validation framework. What does it mean? It's a document codified and submitted in, let me rephrase it. It's a document deliverable that was submitted already and it's accessible. So the process is in place for potential new nodes joining the EOSC. So right now we are working on a testing procedures and validating procedure aligned with this framework. Now I would like to say a couple of words about the technical progress. But before I start, let me separate the technical progress in 2 layers. This particular slide is about the enabling layer, EOSC Beyond core services, that pilot nodes are testing in the sandbox. First major area here is AAI. Like I said before, pilot nodes are testing federated login, proxy configurations, and access flows. The next one is catalog and discovery. Service catalog, discovery hub, and white label marketplace patterns are being integrated for resource visibility. Help desk interoperability, cross-tenant support workflows tested or planned to understand how helpdesk federation should work. It's still ongoing process. Deployment service, Tosca-based deployment patterns prepared and tested for scientific environments and data-aware workflows. Monitoring and operational readiness, monitoring availability and reliability checks included in the validation framework or services. So as it comes to monitoring, for example, it's important because this whole technical integration is not only about can we run it or can we run it once, but also can it be observed and trusted over time. As it comes to help desk, it's where project tests whether support can follow the user across organizational boundaries. In catalog and discovery part or area, pilot nodes are testing how services and research product can become visible through service catalog, resource catalog, and discovery hub patterns, and so on, so on. But it's not only about core services. Second technical layer is the exchange service layer. These are actually the real capabilities that researchers actually want to use and need. So across the pilot network, we see several types of exchange services. First group is data and metadata catalogs, CESDA, LifeWatch, METROFOOD, and more bring domain-specific catalogs or data sets that are being prepared for discovery and access through Discovery Hub. Second, compute and execution environments like EGI Data Hub, data staging, transfer patterns explored for research workflows. Scientific and domain tools that are something also engaged or executed within the project, like cryo-M validation report service from or by CNBSEEC. METROFOOD contributes food data applications and catalogs. Instruct-ERIC brings ARIA and Fandango for storage brokering. So core services are here to make the pilot network technically feasible, but exchange services make it scientifically useful. So that's the difference, but both types are crucial and substantial here. Couple of words about methods and enabling organizational progress and how we work in the project. On the left, you can see that we like a priority is science first. Again, user stories that define the integration work. We do not deal with abstract ideas or architecture. Sandbox-based validation. Pilots are testing their services in a controlled pre-operational environment. We use bi-directional feedback. So pilots' findings shape core service improvements. And from the other side, core updates are tested back with the pilot nodes. MVP as the readiness baseline. So we have a common minimum standard for pilot nodes participation, testing, and further integration. From this methodology, we were able to retrieve some reusable outputs. For example, technical integration report that document with pilot node integration status, service use, challenges, and lessons learned. Testing and validation framework, like I said before, it's deliverable that defines MVP, validation layers, ways of testing and validation of core services and scientific user stories. Then we have user story technical analysis. So before we start working, we had to turn research workflows into service dependencies, interfaces, and integration needs. So we had to make it practical. And we have integration roadmap that is shared timeline for progress tracking to be on a safe side all the time. Lessons learned. There were many lessons and thoughts during the whole project or these 2 years. So we see several practical lessons from this whole pilot network. First, AAI is a real starting point. Pilot nodes that addressed identity and access early were able to move faster with other integrations. Second, onboarding should be simple. If the same service has to be registered several times in different catalogs, we create extra work and endangerment of inconsistencies. The general direction should be register once and discover it everywhere. And we are working on a federated search to meet this goal. A third, Chajdas integration is not only a technical process. This whole ticket routing can work, of course, but the rules of ownership, escalation, and data retention must be defined and acknowledged by every member of the network. Fourth, deployment is only a start or starting point. Templates and containers might help simply, but real operation also needs monitoring, alerts, capacity planning, and support. Data movement must scale, so metadata, data movement, and PIDs are crucial for this whole interconnections and cross-domain workflows. Researchers need data that can be found, understood, and move close to compute. These lessons are not the only ones that we discover or acknowledged, but they are very important here. And they are showing and proving why pilots matter, because they can show what has to be fixed before production, right? So that's the whole idea here.
Kasia, please, let's go a bit
I know.
faster. Yeah.
I'm gonna wrap up. I have just 2 slides, so it's gonna be quick. What we expect next? Complete validation against the MVP, strengthen user stories and cross-node workflows, so the ongoing development of user stories is in place. Improve core and exchange service integration, and turn lessons into reusable guidance. So keep everyone informed. Improve user-facing experience, clarify roles and responsibilities, assess scalability and performance, and prepare evidence for future onboarding. So these are next steps for the final year of the project. And the last slide, things I'd like you to remember: that pilot nodes are not a side activity. They are how EOSC Beyond tests the practical route towards federation readiness based on real-life use cases. Cross-node workflows show the value. The strongest lesson comes from scenarios no single pilot can validate alone. And validation makes progress measurable. So MVP criteria, testing framework, reusable guidance help pilot nodes assess readiness and identify gaps. And now I would like to give the floor. Of course, Federico probably is going to introduce them. 2 case studies, our pilots showing pilot node work in actual practice. Thank you very much. I'm open for your questions.
Thank you.
Yeah, that's
Thank you
all
very much,
from me.
Kasia.
Thank you.
There is actually a question in the Q&A box if you want to address it in typing while we start with Oskar. So Oskar, you are the first from METROFOOD. You can turn on your camera and
yes,
and share your slides. Okay, first use case.
Yep. So just give me 1 second. Okay. So good morning. I'm Oskar Chajdas from Premotec. I'm presenting on behalf of my team. In the next few minutes, I will show you how we integrated METROFOOD-RI, Europe's research infrastructure for food and nutrients, into the EOSC. So yeah, so first, what is METROFOOD-RI? It's a distributed European research infrastructure for methodology in the food and nutrition. METROFOOD provides high-level methodology service to enhance food quality and safety. In the numbers, METROFOOD is present in 18 countries, 48 institutes organized in hub and nodes model. A central hub is coordinating national nodes, and we cover the full chain from analytical laboratories to methods and device and to actual fields, farms, and aqua farming sites. Yeah. This is our pilot node within EOSC Beyond. three things in one sentence each. It provides access to food and nutrient resources across EOSC. It provides fair and reusable scientific workflows, and it targets researchers in food science, health, agriculture, and any other domain. On the right, you can see the architecture in 3 blocks. The METROFOOD block is in the middle. There is our help desk, our catalogs, AI, and some services. The EOSC sandbox is on the top with help desk, discovery hub, deployment service, monitoring. The federating capabilities we plug into. And Edge is on the right. It provides checking for authorization, notebooks for analysis. The arrows show the federation in action. To make it concrete, let's read you 2 scientific user stories that drive our work. First, as a food chemist, I want to compare the nutritional profiles of plant-based foods, product grown in different European regions, using a standardized methodology framework so that I can access geographical variations in nutrient density and potential contaminants. And the second one is, as a researcher, I want to combine food composition and consumption data with socioeconomic indicators across European regions to study dietary quality and support evidence-based food policies. And let's see how EOSC make them possible to answer. To make those story works, we integrated with 5 EOSC core services from the Innovation Sandbox. The first one is Service Catalog. You can see our actual services listed. Some analysis, some nutrient characterization, some advanced food product designs, and more of them. All are discoverable through EOSC. The second one is AI. We are now one of the identity providers alongside with other pilots. The third is the Discovery Hub. So now there is a 21 of our services available in EOSC Discovery Hub. So and it's available for any users. Fourth is our help desk. We have a dedicated METROFOOD queue. Tickets are rounded to the right team automatically. And the last is monitoring. So Argo is tracking the health of our endpoints and apps in the real time across the federation. On our side, we expose 2 main resources to EOSC. One is our data catalog for discovery of food data and services. And the second one is RM app, our reference material application with instruments and certified materials. Now let's bring everything together with our first user story in action. So now meet Anna. Anna is a postdoctoral researcher in plant-based nutrition. Here's her workflow. She starts at the EOSC Discovery Hub, searches for food composition database, and she finds out METROFOOD data catalog with nutritional data plus soil and climate metadata. She logs in through the EOSC AI, and she's now able to access the catalogs. From the EOSC marketplace, she also discovers the EGI cloud compute for large-scale analysis, same login without new account. She can run statistical and machine learning analysis on the METROFOOD datasets in the cloud. If something breaks, she can use EOSC help desk to create the ticket to the right team, either us or some edgy support. So it's one flow, one identity across all nodes. So yeah. And what's the next? We have few priorities. We want to launch search and compare app. We want to integrate search and compare app for side-by-side evaluation of food datasets and reference material. We also want to integrate with OpenAIR to capture a broader range of food research outputs. And we want to make some more interoperability and validation testing. So that's the plans for us. Yeah. And I think that's it from our side. Thank you for listening. Here you can grab some links to check what we did. And thank you.
Thank you very much, Oskar. So again, to the audience, if you have any questions for Oskar, please post them in the Q&A box so he can pick them up. And up next is Lucia Vaira from LifeWatch. So please turn on your camera and share your slides.
Yes. Oskar is still sharing and I cannot do it. Okay, now yes. Okay. First of all, sorry for my voice. I had no voice until yesterday, so I hope that you can hear me. So
Yes.
good morning, everybody. This is Lucia Vaira. I'm the Service Center ICT Core. I'm Service Center Coordinator of LifeWatch. I'm presenting this the pilot node activities that I do with my team. FDKI is here and Joaquin also from ICT Core that cannot attend the meeting, but he also contributed. So just some words about LifeWatch for who doesn't know it. We are the European research infrastructures that provides key science research facilities to all our stakeholders in order to investigate biodiversity in the ecosystem functions and services, with the final aim to support society in addressing key planetary challenges. Oops, sorry, it was fast. Our pilot. So the main aim was achieve the full interoperability with core EOSC services in order to enable the broader accessibility and reuse of our services in LifeWatch across the entire EOSC ecosystem. In order to represent and present the pilot at a glance, you have the link here to have more details, but in general, we focused on 4 interconnected work streams. The first one is about user story, as the other pilots also will show. So the possibility to define, design, and develop a role action benefit scenario, so an actual and real researcher user story that is grounding the entire technical work. Then the AI integration that was done in our case at the very first steps. So we addressed it immediately, luckily. Then the catalog federation that requires a lot of time in order to be completed. That is about integrating our LifeWatch metadata catalog that currently hosts 6 kinds of resource types. So we have datasets, services, virtual search environments, workflows, research sites, and training resources. So the objective is, again, also here to have the EOSC, to be compliant with the EOSC standards for improving discoverability. And finally, the help desk integration. We had the bidirectional synchronization of help desk with the EOSC one in order to support the end user. This is only a diagram saying what I've said before, just to show you the main entities, let's say, behind these pilots. So obviously we have the LifeWatch node, the EOSC Beyond one, and then also the EGI infrastructure, just to show you that we use the EGI for the infrastructure management and compute and storage of for our user story. So this is the user story. Again, I put the link here of the video where FTK explains all different steps, but considering the role, action, and benefits, we started from concrete user needs of a researcher, an ecologist, that wanted to analyze biodiversity patterns, focusing on presence and distribution of alien species in the ecosystems. So the researcher needs a service, at least a service or a workflow in general, that is able to integrate, clean, and analyze biodiversity data while ensuring at the same time consistency in taxonomy and alien species classification. So the user journey, you can see it in the right of this slide. The user goes in the EOSC Discovery Hub and starts to search something by directly browsing the hub or putting some texted search keywords and discover the service. Then when the researcher is able to find the service which she is interested in, can read metadata, the full enriched metadata record, in order to understand which is the purpose and how it works, so the main functionality. Then she decides to select it, let's say, so can log in, launch, and use the service. The steps 4 and 5 are in brackets since it's like what is acting behind the scenes. So the deployment service provision of the computational environment that is needed in order to do it. And datasets that are used in this user story are automatically collected, automatically retrieved via the EOSC knowledge graph. The help desk is always there in order to support the researcher, so the final user. So at the end, the researcher is able to access and use a Jupyter notebook and run a workflow that is able to integrate 5 biodiversity datasets from different ecosystems, and is able also to do what was the first purpose, let's say. So clean data, validates taxonomy, flags alien species, can calculate the abundance, and also visualize the map at the end. All of this without any special or detailed knowledge of the technicalities that are behind the workflow execution. So this is the added value, let's say. According to the different integration, the AI was done at the very beginning, so researchers can sign in via LifeWatch, Google, directly through the Federation of EOSC. So in order to remove also the classical authentication barriers in order to access services. For catalog integration, we had mostly 5 main steps. Obviously, some of them were constituted in several steps inside, but we registered the provider. Then we developed an XSL adapter, an ad hoc adapter, in order to map our metadata schema for datasets that is based on EML 2.2.0 to the datasite 4.0, that is the standard that OpenAir is using currently. Then we developed and implemented the OAI PMH endpoint in order to allow the harvest of our dataset resource records in the EOSC knowledge graph via OpenAir knowledge graph. We registered the data source in the Discovery Index, and we published our service in the Discovery Hub. In this first phase, manually, then we will do it automatically as next step. For the help desk integration, we have this bidirectional integration that I told you before. We have a dedicated adapter that is currently operating only on test instances of both systems, but we will put in production very soon. Just to have an overview, we developed 6 main REST APIs, target, post, and patch, in our help desk in order to power this bidirectional synchronization. And how this synchronization is triggered, a user can create a ticket in the LifeWatch help desk by choosing the topic EOSC, and the ticket is automatically sent to EOSC, or vice versa. A user can create a ticket in the EOSC ecosystem under the pilot LifeWatch, and is automatically created, or we can use the ticket escalation. So in both systems, we can have a ticket, and the administrator of the help desk can decide to move that specific ticket for the second level subject. So to conclude, which was the biggest challenge? It was hard to explain in a single sentence. We have tried to analyze everything that we did, because the main issue that sometimes was really blocking in order to complete the activities was understanding how to get federated. So navigating all requirements, constraints, guidelines, the naming conventions is something that is still struggling for us, and all implementation details. The side effects, let's say the collateral challenges, are obviously those related to the synchronization activities that obviously in a European project, but in general in a federated environment, between work packages, tasks, the people that are involved, so waiting for tasks to be completed before starting the new one and stuff like this. But the key lesson learned is that the complexity is the default, is normal in a federated environment. But what is important, what is relevant is that we have a clear, shared and recognizing aim that we want to pursue. So every integration challenge that can be solved is a step closer to the final aim, so the objective. And finally, next steps. Again, we have three main work streams, but they are interconnected as well. We are going to implement the node registry functionality and then establish also the monitoring in order to ensure the service reliability and compliance with the standards. We are going to develop also 2 cross-pilot user stories, so that we can also enable rich and cross-infrastructure research workflow. And finally, since now we have the new service metadata schema by EOSC, we are going also to implement and deploy the full service federation. So all LifeWatch services will be onboarded automatically in the EOSC ecosystem. And that's all. Thank you.
Thank you very much, Lucia. So we move to the third and last pilot presentation by Yvonne from Instruct-ERIC.
So I hope everyone can see this.
We see the back end.
Oh, back end.
Maybe you have to switch the displays.
Oh, okay. Oh, I thought we tested earlier. Let's switch.
Yeah, just swap displays. It should be.
The display. Swap to display. There you go.
Yeah, there you go.
There you go. Today, good afternoon, everyone. I'm Yvonne de Jong-Leung from Instruct-ERIC. So today I'm concentrating on this user story of ours. So Instruct federated storage to leveraging EOS to federate access to different cloud storage provider. So to start with, it's well understood that every research products under our eye is to make it findable, accessible, interoperable, and reusable. And the researcher typically produce data at the facility and publish the processed data to a public repository, and may discard the raw data or to hold it indefinitely. So the problem here is the raw data can be lost if the facility has no way to store it and to make it fair. And typically for a larger data set, smaller facilities are often unable to store the data for a prolonged period of time. So the EOSC Federation offered an opportunity for us to explore the federated data storage. For Instruct-ERIC, we have begun to explore the federated data storage from facility via our management tools, ARIA and Fandango. So to support Instruct researchers and facility, the Instruct management platform, ARIA, has been extended to storage brokering service, which provide a central point from which storage can be provisioned, ideally from multiple providers. But currently, we have supplied by EGIs via the EOSC Polish Note 1 data. And for facility to choose to access the provisioned storage, we have two ways. To deploy Instruct Fandango, our LIMS management tool, which can also provide the functionality to interact with ARIA, or directly interface with ARIA itself. And to use these tools and service, the Instruct Nooks is able to store the raw experimental data from the Instruct visits. We can link to the researcher's report held in ARIA. And this data can be published via EOS Sandbox after the embargo period to reach wider audience and to make the data fair. So the Instruct Nooks user story here is to take the form of new service to be provided by Instruct via the EOS Sandbox that provides a facility with a network for data storage that can be accessed via our on-site tool, ARIA and Fandango. And data stored in the Instruct storage network will be made publicly by publishing it to Discovery Hub for the wider audience and to be reused. So our next step action is, as I mentioned before, currently we have one data. So we would like to have more storage provider, and we are in talk with EU Notes and EU DAT, in which EU DAT have several providers are interested in this user story. So also we have to retrieve the embargo date from our data deposition API via Fandango to trigger the publish function in one data. And also make this publish link available inside our management tool ARIA as well as OpenAir, and to make the data fair. And this is the end of my presentation. Thank you very much.
Thank you very much, Yvonne. Thanks, everybody. So maybe if the panelists want to turn on their cameras for this quick Q&A that we have now at the end. I see that two of the questions were already addressed in the Q&A box. So maybe, Kasia, maybe you can pick this one up in speaking if you want, the one about the Discovery Hub. Are you there? Can you hear me?
I'm sorry.
Yes, yes, this question about the
Answering your
Discovery Hub.
question,
Okay.
but without any voice. Yes, I'm answering right now to Helen. We have a special website. This is Discovery Hub. I can put link in the chat. It's the place where you can browse and discover resources. Of course, it's a pilot project, so it's not a production version, but you can test it. You can go through its features and functionalities. So please, you are welcome to test the Discovery Hub. Like I said, you can discover and access services, publications, in general, services, data spaces, data sources, and research products.
Okay, and then there was another question, which is, okay, so if I'm an external organization, like an external provider that's not directly involved in EOSC Beyond, is there a way for me to get in touch with the team?
Of
What
course.
can be done?
Yes. It's on the Sandbox website that I'm again pasting in the chat. You can fill in the contact form, and it goes through help desk, and it's being escalated to proper recipients. So yes, this is the place where you can contact us and ask any question, and maybe offer joining to our network or working with us on integrations.
Thank you very much. Okay, I'm just doing another quick round of asking if there's any other question, like any other open questions from the audience. You can also raise your hand if you want, and then we can allow you to speak if there's anyone. Let's see. Okay. Well, so thanks everybody. Then just note that you will be able to find the slides and recording from this presentation on the EOSC Beyond website, probably tomorrow morning. And just make sure that you follow our channels and you sign up for the newsletter. And we look forward to sharing more progress with you in the future months. Thanks again. Thanks to all the speakers.
Thanks to you.
Thank you
Bye.
very much.
Thank you.
Bye.
Have a good day.
Thanks,
Bye.
bye.